In this class, let us discuss classes. This is another type of non-primitive data type, which non-primitive data type in the sense user-defined data type. So, which is class. So, here a class is a group of objects that has common properties. It is a template or blueprint from which objects are created. The objects are the instances of class. Because an object is an instance of a class, you will often see the two words object and instance used interchangeably. A class is used to define new type of the data. Once defined, this new type can be used to create objects of its type. So the class is logical entity and object is the logical and physical entity. The general form of the class is class identifier and type instance variable 1, type instance variable 2, and so on, type instance variable n. And we also have method type method 1 parameter list body of the method 1, type method 2 parameter list body of method 2. So likewise you will have n number of methods. So the class will be having instance variables and methods. So the methods and instance variable collectively called as members. Variable declared within the members methods are called local variables. The data or variable defined within the class are called instance variable. So a simple class, let us discuss a simple class. So class box and its instance variables are double width, double height, double depth. Now let us create an object using the above class. There are three steps when creating an object from a class. So declaration, a variable declaration with a variable name with an object type. Instantiation, the new keyword is used to create the object. Initialization, the new keyword is followed by a call to a constructor. This call initializes the new object. So let us say with the class name box B, uh, declare the class variable. Here the class variable contains the value null. An attempt to access the object at this point will lead to compile time error. So the step 2 is box B equal to new box. Here new is the keyword used to create the object. The object name is B. The new operator allocates the memory for the object. That means for all instance variables inside the object, memory is allocated. So width, height, depth, the memory is allocated by the new keyword. There are many ways to initialize the object. The object contains the instance variable. The variables can be assigned values with reference of the object. B dot width with some value, B dot height some value, and B dot depth some value. Here is a complete program that uses the box class. So class box double width, double height, double depth declares an object of type box. Class box demo public static void main string arguments declaring the object and instantiating object box. So box my box equal to new box double volume. Assign values to my box instance variables. My box dot width equal to 10, my box dot height equal to 20, my box dot depth equal to 50. computing volume of box. Volume equal to my box dot width into my box dot height into my box dot depth. System dot out dot println volume is plus volume. So when you compile this program, you will find the dot class files have been created, one for box and one for box demo. The Java compiler automatically puts each class into its own dot class file. It is not necessary for both the box and box demo class to actually be in the same source file. To run this program, you must execute box demo.class. When you do, you will see the following output. So volume is, as stated earlier, each box object has its own copies of instance variables. This means that if you have two box objects, each has its own copy of depth, width, and height. It is important to understand that changes to the instance variables of one object have no effect on the instance variables of another. For example, the following program declares two box objects, class box demo2, box my box1 equal to new box my box2 equal to new box double volume. Assign values to my box instance variables. My box1 dot width equal to 10, my box1 dot height equal to 20, my box1 dot depth equal to 15. Assign different values to my box2's instance variables. My box2 dot width equal to 3, my box2 dot height equal to 6, my box2 dot depth equal to 9. Compute volume of first box. Volume equal to my box1 dot width into my box1 dot height into my box1 dot depth. System dot out dot println volume equal to volume is plus 1. Compute volume of second box. Volume equal to my box2 dot width into my box2 dot height into my box2 dot depth. So system dot out dot println volume is 1. So assigning object reference variables. Object reference variables act differently than you might expect when an assignment takes place. For example, box B1 equal to new box B2 equal to B1. You might think that B2 is being assigned a reference to a copy of the object referred to by B1. That is, you might think that B1 and B2 refer to separate and distinct objects. However, this would be wrong. Instead, after this fragment executes, B1 and B2 will both refer to the same object. The assignment of B1 to B2 did not allocate any memory or copy any part of the original object. It simply makes B2 refer to the same object as does B1. Thus, any changes made to the object through B2 will affect the object to B1 is referring, since they are same object. This situation is depicted here.